Good morning. Here we are again for part 2 of lesson 18 or lecture 18 of CENG 4412 Steel and Concrete Design. This video is going to be to give a very short introduction to the sort of design aids for for steel column axial design, compression design. Okay, so for our design aids, there are a variety of tables we can use. Basically, most of the tables in Chapter 4 relate to column design. So design aids for columns. This is your Chapter 4, and there's a whole bunch of them based on different shapes with different arrangements, etc. Okay, so here, if you look on, let's go to table, let's turn to table 4.4-1A. So for example, table 4-1A, 4-1A. This says the available strength and axial compression in kips for W sections. In axial compression, for W sections. And this is a very long table because we know that the strength of columns is going to be based on their length. So what they have here, at least here, they have a whole bunch of different pages, different tables for different shapes. So for example, if you look on page here, 4- again, this is on the 15th edition. If you're on page 4-13. This is for a selection of W14s. Well, actually, probably starts on 4-12. W14s on on let's say page 4-18. They have W12s. And so this whole page, for example, on 4-12, covers W12 sections, covers W14 sections. And if you look, so again, this entire table is about nothing but W14s, and then in the different columns, they have this listed for various individual W shapes. And notice though, so in the so for these tables, you'll have W14 by with different columns that are like your 873, 808, 730, etc. And then it lists its VPN and its PN over, well, basically you have your ASD and your LRFD. So you have your VPN and then your PN over omega. But we're only looking at LRFD in this class. But what it is crucial to keep in mind here is that this takes into account the effective length. So basically, as we go down here, it has LC. With respect to the least radius of gyration, which is basically for all of these going to be your RY. So this is your effective length, basically, or sorry, your column length. Column length times what? Times the this. Okay. Column length times your effective length factor. Sorry. Basically take into account your support conditions. Now, notice also that these tables are arranged according to a particular yield strength. So this table here is arranged is set up only and has all its calculations for 50 KSI steel. But if you go on to some other sections, such as table B 4.1b, there's one for 65 KSI steel. So it is exceptionally important. Again, this is one of those things where design aids can be very useful, but they are very dangerous. And they're very dangerous because you need to make sure you're using not only the right value for your particular section, but you're using the right table for the correct yield strength of your material. So that can be useful, but also we can very clearly see the relationship between length and capacity. So as we go down a column, we see that as the column gets longer and longer and longer, the allowable strength or the design strength of the column is going to decrease. And so we can clearly see the relationship between length and design capacity. And there are other shapes as well. So, and there are many other tables in here. Most of these up to, let's see, so for example, Basically all of table 4.1 is going to be this sort of thing for W shapes. 4.2 is the same thing except for, let's see, the same thing except for HSS shapes, hollow square tubing shapes. 4.3 here, let's see, here more HSS. More HSS, oh sorry, actually this was HP shapes, sorry about that, HP shapes. 4.3 was HSS. 4.4, if I keep going down, is square HSS. And 4.5 is round HSS, or round, not round HSS, well yeah, just round HSS. Round hollow square tubing, which definitely has a bit of a weird ring to it. And then 4.7, 4.8 are very similar. And you basically have a series of design tables going down through the calculations of these 4 particular members. Then, let's see, we have other things. Moving on to table, let's say 4-14, then we get something interesting. This is the available critical stress for compression members. And this can be very useful for design in terms of selecting a section. This one can be very useful when just designing a column. So you have basically you have a series of FYs and you have a series of lengths, and then based on that you can find the, well basically the allowable or the required or the available critical stress, effectively your FCR. But that can be useful as you work through your design, because then once you have your FCR, you can use that to calculate your gross area, that sort of thing. You can basically use this to get your FCR very quickly, and then from that you can just use this to get your gross cross-sectional area required for a given axial load. Okay, but and we could talk more about this, but that's just that's just at a very basic level how you can use some of these column design aids. However, as always, I always feel I need to be careful. I always feel I need to state this when talking about design aids of any type. Be careful. It is very important to only use the table that corresponds to your applicable case. You must be aware of the assumptions present in the table. Know the assumptions present in the design table. So read all the notes. Read all the notations, read all the sidebars, read all of these things, know the assumptions built in to the design aid. Design aids are useful, but they are also dangerous if you don't know what you're doing. Okay, all right, that'll do it for this portion of the lecture, and we'll continue on with part 3.